Hey everyone, good afternoon. So today's session is on cross-platform data lineage with OpenLineage. We have Julian and Willie here who are going to be presenting. They are from Astronomer. Julian is the chief architect, and Willie is the lead on the Marquez project. So yeah, we're looking forward to a very cool session with a great demo. If there are any questions, please hold them off till the end. We'll have some time for Q&A. If your questions don't get addressed, we can take them outside once the session is over. And yeah, with this, Julian, I'll hand it to you.
Thank you. Hello, everyone. So I'm Julian, and this is Willie. So today we're going to talk about cross-platform data lineage with OpenLineage. So I'll start with explaining a little bit the problem and why lineage and how it's solved and so on. I'll talk about OpenLineage and Marquez. OpenLineage is an open standard for lineage collection, and Marquez is a reference implementation for collecting lineage. And then we'll go about how to build data observability across your ecosystem from Spark to Airflow to Flink to dbt. And we'll end with a demo using Marquez and some of those things. So stay tuned. It's going to be more hands-on in the end. So first, the key to a lot of those problems is data lineage, right? And depending who you ask, there's a very different definition of what lineage is for and what you can use it for, and what problems it solves. And so we're going to go over a bit why we're saying lineage is so important and why collecting lineage is so important. Right, so if I go back a bit and I build up on what the problem is, often within each team, there's very good understanding on what the data practices are. Like each team knows well what pipelines, what data transformation they're responsible for, how it works, how they work together, how they make changes. But in between teams is where the friction happens, right? Like there's very little visibility most of the time on what the other team is doing, and we're depending on data they're producing, or someone is consuming the data we're producing, and we don't know what they do with it. I don't know if they still use it anymore, and we don't necessarily know who to talk to when we change something. So a lot of the friction comes from, we've been talking about big data, but it's kind of like the organization and having many people around using that data is often the problem where scaling the organization becomes a problem. And that comes from this limited context that people have around the data, where there's this data set, but there's a lot of missing information around it, right? What's the schema? How is it evolving over time? Who's responsible for it? Who's taking ownership? How often is it updated? Where it comes from? Who's using it? What changes? And this kind of general lack of context on how this data set changes or who is responsible for those changes. And so I've been stealing this, there's this Maslow's hierarchy of needs. And if you don't know it, there's a little bit of, before you think about reaching happiness and self-realization, becoming the best version of yourself, you first need to fill some basic needs, right? You need shelter, you need food, you need safety, and once you build those things in your life, then you can, try to reach happiness and make everybody's lives better. So in data, it's a bit the same, right? Like first, you need to make sure the data shows up. Like, do we even have the data at all? Second, that it stays up to date, right? How long does it take to update? Maybe it's just stalled data. There's some problem. And we need to know that it's correct, right? So once you build these basic things, then you can keep your head above water, right? And start saying, okay, how do we optimize our business now that we actually see what's going on? How do we create new opportunities? How do we build on that data and create things? So a lot of the time, we spend a majority of our time just grinding and just keeping the data up to date and correct. And that takes so much of energy compared to getting value out of it. And so our statement here is that OpenLineage is the solution. So we were seeing a lot of different systems. We're trying to extract lineage, reverse engineer data warehouses, machine learning frameworks, everything, like trying to extract lineage from all those things, put it in one place. Right? But the statement here is the only way we're going to solve this as an industry is by getting together, define a standard on how we expose lineage. Everybody exposes lineage in the same way. Everybody consumes lineage in the same way. And it simplifies this problem a lot. And it avoids this problem of having a moving target that's always broken. So OpenLineage is about defining an open standard for the collection of lineage as it's happening, right? As the jobs are running, because that's when most of the metadata is available, rather than trying to, after the fact, get from logs or other things that might exist, but that were not designed for it. And so we bootstrapped this project by reaching out to a lot of people in the community, a lot of open source people. You know, I've been working in open source for a long time on Parquet and other projects. So it's kind of using those connections and say, hey, we need lineage. And everybody is like, yes, we need a lineage standard. Why doesn't it exist already? Well, it's not just going to happen, right? We need to kind of put some effort in it, get together, agree on how we're going to do it, and do it. So I give some examples here of like either people, maintainers of projects, or companies who've been in. I see some people who are now committers have been joining this effort. This is great. And so this is like a quick overview. There's some people missing on this slide. That's some newer integration that exist, either on the producer side, like open source or proprietary things, and on the consumer side, like data catalogs, data quality, like data management things. And so as I was saying, you know, I have this picture of what is the best time to collect information. Right? When you look at the picture, you can infer information of like when it was taken or where it was taken by looking at the picture. Maybe you use machine learning to extract this information. However, the best time to capture this information is when the picture is taken. So modern cameras, they capture the GPS coordinate, they capture the time, you know, where it was taken, what kind of aperture you use, what was the lens on your camera, and all of that. So OpenLineage is the EXIF data for your data, right? It's capturing at the time the data is being transformed or being created, all the metadata that's available then, because that's where you're going to have the best collection of metadata. Sorry, I was going to say the clicker is too sensitive, but maybe I pushed the button too hard. So before OpenLineage, and I put some examples here of open source, other projects. You may see yourself in the picture. And before everybody's talking to everybody, we have to reverse engineer all those systems. We have to talk to all those partners, figure out how we connect lineage. There's a lot of replicated effort. There's a lot of wasted effort in that sense. It takes a lot of time. Everybody feels like, oh, it's an untractable problem to extract lineage. And it costs a lot, right? So, and it's also a moving target. When you reverse engineer something, depends on the internal. When it changes, it breaks. You have to do it again. So OpenLineage is here. It simplifies the entire picture. And then everybody can work against it, and it's a lot simpler. And then there's a snowball effect, right? The good thing about this kind of project, the more people adopt, the more people use it, the more valuable it is for people who are using it, and the more incentive there is for more people to use it, right? Like the more the ecosystem grows, the more incentive there is for other people to join the ecosystem, and then it grows, and we get to a very healthy community. So I'll go a bit faster on how OpenLineage works. So there's a series of events. A lot of OpenLineage is about making a parallel with open telemetry. Open, you know, in the service world, there's a very clear way we do SLAs, we understand how we operate those things, how we extract metrics and traces and all of that. In the data world, there's a lot of the similar notions, but with a slightly different model. So we send a start event when the job starts. We send a complete event when the job finishes. If the job fails in the middle, there's a fail event. And it's connecting a lot of metadata around each of those events. So you have this run state update event. it captures the job. The job is the recurring thing. If it's running every day or every hour, this is what the job is. This is a single ID that identifies a thing that recurs. So it could be a Airflow job. It could be a cron job. It could be something else. The run is the identifier for the actual run of that job, like for that particular hour of the day. That's what the run ID is going to connect the start and the complete event. And the datasets ID connect the inputs and outputs. And on each of those entities, you can add facets. And facets are the thing that enables specialization and adding metadata, right? One thing that makes the spec easy to improve as a community, instead of a big monolithic spec, we define facet for each small metadata aspect, whether it's the schema, the column level lineage, the data quality metric. All those things can be defined independently, which makes it really easy to specialize the spec to specific use cases of the type of metadata you connect. And in the sense, the way we connect Lineage is by using those dataset ID, and you know that something is running. It's reading from a dataset, writing to a dataset. This other job is reading from the output of the previous one. And because there's a standard naming convention on how to identify those datasets, that connects the lineage together. And so I went over some of the facet examples of what we capture for each of those entities. And in the end, where OpenLineage fits, the goal of OpenLineage is to be just a spec. And you have producers that produce OpenLineage, and you have consumers that can consume OpenLineage through a series of different protocols. So typically, people use HTTP, like just posting event over HTTP, or events over Kafka. And those are ways those events can be consumed and used in different systems. And so on that, now that I've done the overview, how that works, we'll take over and talk a little bit more about the applied part of this spec.
Great. Oh, yeah, round of applause, yeah. So as usual, Julian does a great job at introducing OpenLineage, sort of the structure, the pain points, and processing data. Sort of, you constantly have to look at ways to troubleshoot your pipelines that are failing. It's sort of a black box sometimes for your data team, and you have to create these silos. So our goal for OpenLineage, but also Marquez, is to make sharing data easier. So I'm going to go over data observability with OpenLineage in practice. But first, I want to talk about what OpenLineage powers. There's going to be 3 pillars. There's going to be data reliability. So when I talk about that, I talk about data freshness. How often is your data updated? How often is the shape of your data changing? Is it being moved around? Is it being replicated? Is it in partitions? So all those things are really important when you start processing data at large. Then you have data quality. So how do you ensure that if you're processing data, it has the parameters that you're looking for? Are there a lot of nulls? Are there gaps in data? So data quality is a really, really big aspect of what OpenLineage can provide through, as Julian mentioned, facets. And then you want to do impact analysis. All of us here have written data pipelines, and they have broken someone else's pipeline. We want to avoid those scenarios to happen because they do cost both time and energy, and we don't have time to waste, right? We want to be writing code and driving business value. Data recovery, that's going to be another one. We're looking at reducing the time to resolution. Right now, when there's a data outage, especially if you don't know where the code change happened that is producing errors in your dashboard, that could take weeks, and weeks could sum up to a lot of money. And when you eventually find the issue, how do you begin to do the backfills? How do you know what pipelines dependent on this data set that now is breaking? Or sometimes it's not breaking, it's just producing invalid values. And data audit is also another big one. So associating cost to teams, because everyone likes to use cool new tools. I mean, we're at a Databricks conference, so maybe you don't have to worry about that. But some companies build things in-house, and how do they begin to associate cost to the teams? And also data compliance. So this is just PII, making sure that when you go through these compliance checks and someone says, do you have user data? Is it in plain text? Can you identify it? And I do want to mention, so we both work for Astronomer, and we build data observability on top of OpenLineage. So we have Airflow that deploys in an Astro environment. We have OpenLineage integration installed, so we have an Airflow library, goes through a stream. You can see some raw events, and we get to process and store and continuously analyze. And there's 3 main products that we focus on, and my team focuses on, which is alerting. So we use OpenLineage to start triggering if your pipeline or tasks are failing or taking too long. We have our Lineage component, which is backed by Marquez, but we have our own product on top of that with custom APIs and some dashboards just to give you some detail on your run history and historical context on just durations over time, because your runs might take long. So with that, now I'm going to go into Marquez, and this was an open source project that was started at WeWork. So Julie and I, we worked on the next-gen data platform for WeWork, and one of the projects that came out of that effort was Marquez, and now we're continuing the effort at Astronomer. Great. So what is Marquez? Marquez is an open source metadata service for operational lineage, and that's really for the data engineer. When pipelines fail, you want to be able to, one, figure out, is this your pipeline or is it someone else's pipeline upstream that is causing the problem? So Marquez, like I mentioned, open source, is part of the LFAI and data, and it's currently in the incubating stage. We are very excited. I think we're close to graduating this year. We are a reference implementation of OpenLineage, so if you look at OpenLineage and you look at what the Marquez model is, it's going to be a superset of what the core entities of OpenLineage are. It's also centralized metadata stores, so you're going to have details around job, data sets, and sources, and a bunch of other features as well. And the one thing I do want to point out is that it's very simple to deploy. So you have operational, and design is very simple. You just have a Postgres instance and the API that's running. And on the right, you'll see things are collected through a REST API. The model itself is very precise but highly dimensional. So what do I mean by that? The jobs, data sets, and runs that you saw in OpenLineage, we now have that in Marquez, but we have versioning of the metadata on top of that. So there's a bit more involved here, but every time you have a job run, it's going to associate that with a run ID, which is coming from OpenLineage, and then we begin to populate the tables as needed. So what are the inputs and outputs? What is the job metadata that's contained within the OpenLineage payload? Quickly, design benefits, there's 2. There's debugging and backfilling. So like I mentioned before, pipelines have failed and will continuously fail, and you want to be able to ask the question, when was that bug introduced in your pipeline? And Marquez is able to version your data sets, version your jobs, but also the output data sets as well. And mostly when we talk about versioning, we talk about changing code, but also the change in shape of your data if you're adding, removing columns, or renaming data types. And once you figure out what the problem was, you can run backfills. So you'll be able to understand what jobs depend on your data sets by just running a lineage query and understanding all the jobs downstream that might be affected by that data set that may have been corrupt for whatever reason. And we want to make this sort of cut across the data platform. So really high level, you start from left to right. You constantly see observe, correlate. So anytime you receive an OpenLineage event, we create this flow, and it's constantly observing the data, the job itself, and correlating it with the data set. So on the bottom, you'll see data set names linked to job runs, and that's how we keep the relationship on the Marquez backend. And we have the job run. So here's a payload, really simple example. You have the observe, which is the run ID, and that's how you're able to essentially trace all the different states of the job that you have, and also the inputs and outputs. But here, we're just correlating the inputs. And quickly here, yeah, this one, this is now going to be a complete event. So before we had a start, here's a complete, and now we're correlating it, and we have the outputs here. Before, we just need the inputs. Now we're just defining the outputs. And collecting all this in a nutshell, if you look on the left, we have all these integrations that have been actively being worked on in the community, some who are present in the audience now, which is amazing to see. And we stitched together this lineage graph and post it through the integration and send it to the Marquez backend, where you can see the model itself gets populated. And this is where I would like to announce that there is going to be a lightning round of information because we want to get to the demo. So I'm going to quickly go through high level what we support, how to configure, and how to go through and execute some of this on your data processing apps. So quickly, in Airflow, what do we have? We have metadata. We look at the task lifecycle parameters. All that is really important. And especially if you're versioning your code, we do have this built-in SQL parser, which allows you to then, if you're modifying your code, we can build a GitHub link and extract metadata from your DAG. And on the left, you'll see OpenLineage is installed, and all the DAGs that execute will be able to emit the OpenLineage event. To configure, currently at the moment, it's just a plugin. So you'll be able to, it's part of the OpenLineage, it's part of Airflow under plugins. And at a high level, there's an adapter that starts your task, completes, and fails. It gets passed in a run ID and the task itself. And that's where we begin to extract metadata and send it to a OpenLineage compliant backend. So what does that look like? Pip install and set your OpenLineage URL. In this case, if you're using Marquez, great. You could just fill it in with that detail. If not, building something custom, you could send it to that backend as well. And to configure, you could do the airflow.conf, and there's an OpenLineage section where you can disable, enable, provide custom extractors that you might have internally and define a transport. So where should we send these events? And in Spark, very similar, we look at the query execution listener. So we use that to look at the different states of your Spark app and look at the logical plan. And we have our own query plan visitor that looks at the inputs and outputs. And then that builds the payload as an OpenLineage event. And now we have the inputs and outputs for your Spark job. And built in, out of the box, you do get column level lineage. I think that's pretty exciting. A lot of work went into that. And there's a facet that will be sent along with the OpenLineage event. And you get data quality metrics out of the box as well. So bytes, row counts, that's all included. And this just goes through the query execution plan. You start out with data sets, you have the logical plan, and then the physical plan, and now you have your RDDs. So that's the flow that we're looking at. To configure, in this case, we just have, or the implementation is the Spark. We have an OpenLineage Spark listener. We've extended the Spark listener for Spark. And inside, we have our details on how, in this case, you could look at our GitHub repo, and because all this is open source, and you could check out how we're processing all of this. But importantly, metadata that we do collect is the logical plan, some environment properties, and also information about the data sets. And to configure, you run through your shell, and, or if this case, if you're just going to run it, the PySpark, you just provide your jar, in this case, OpenLineage Spark, give the version and the extra listener, and start up. And once you execute your Spark, your workloads, you'll be able to get information on the back end. In this case, wherever you set that transport URL, it will emit the events too. And in Flink, another quick one, we use the job listener. This is more work in progress, so I'm not going to go too much into this, but if you want to help out, that'd be amazing. Currently only supports application mode, but we're getting some checkpoint metrics, which is awesome. And we currently support Kafka sinks and sources. And if you guys are using Iceberg, there's also an Iceberg source that we support. More details on how to configure this. Again, you'll see there's a lot of built-in wrappers that we have, so that's going to be a common theme. And to configure, you just have to pass in your stream execution environment and register the listener. And underneath, you'll see that OpenLineage has a YAML file, and you can define your transport there. And finally, in dbt, this one I think is one of the simpler ones because dbt does such a great job of extracting metadata already that we didn't have to do much work. We just have a wrapper, and when you do your run command or any subcommand, it will then start parsing out the details, the manifest files that are available in dbt, and register that metadata to the backend. Configuration, quite the same, pip install, and set your OpenLineage URL, and then do dbt run, and now you have OpenLineage on the backend being sent. So here, for example, we emitted 4. Okay, thanks for staying with me. Now, the demo. All right, first we have Marquez running, so there's nothing up my sleeves here. We have a running instance, and we also have Airflow. So if I do if I do astro dev ps, you'll see I have Airflow running. And if I go to the UI for Marquez, we currently don't have anything set up. It's just a clean instance. Now I do have an Airflow DAG, so under my orders analysis, I'm going to go ahead and trigger this, just so that way we can get metadata sent. This is just looking at products and looking at the monthly, in this case, so we're going to import some orders, we're going to summarize the months, and then we're going to find which one is the most popular product. So nothing too crazy, and also very common. So in this case, we just completed, so if I go back to Marquez, and I just refresh, we'll see that now we have the jobs. In this case, there's a certain convention that we have for different integrations. So I'm going to click on order analysis, find popular jobs, but on the right, you'll see the namespace, you'll see when it was last updated, the duration. If I click on that, you'll just see a very simple lineage graph. And underneath, you'll also see the latest run. You'll see what SQL was parsed, but also what SQL it ran. And underneath, you'll find the OpenLineage facets themselves. So that is also a really awesome thing to know how this graph was eventually rendered. But you could also see the immediate input data set as well as the schema. So you see the names of the fields, the type, as well as the description if it's present. And you'll also look at the output data set. So in this case, the output data set is called public top products. You also see the versioning, so we also version the schema, so any changes that happen will show up here, and you get a new version ID for your data set. So next, I'm going to run Spark really quick. I have a script here that is going to run, let me see if I just do Vim real quick. And it's going to install the jar, like I mentioned before. It's going to set Marquez as the backend, so in this case, localhost 500, and we're going to send the events to our running Marquez instance. So I'm just going to run the script. Cool, now we have a shell. Oh, I do want to allow. If I go up, I'm just going to read an inventory CSV file. Now we have it as a data frame once it loads up. And if I do the print schema, so again, it's not really that interesting. And the next thing, we're going to group it. So we're going to group it by product and just kind of say what's in stock. And if I go back to the Marquez UI, and I look under the events, this will give you a complete catalog of all the OpenLineage events that we've collected so far. And here you'll see that we have the Apache Spark collection limit. So this is the job that we just ran and executed. You could look at the facets. I think the more interesting thing will be the Spark version. So if you want to know a version of Spark that you're using, and also if you want to look at the logical plan, that's also here as well. So that's being shipped. But you could toggle that on and off. Okay. And then finally, I have this custom, organizations are going to have custom code. You'll have to do custom integrations. I'm just going to use the curl command. And if I look into some of these, if I do a list, yeah. So I'm going to complete a job, start a job. Look at JSON. This is the most minimal amount of information that you need to send it to the backend. So you need the run, you need the job, and also the inputs. In this case, we're going to be reading from an input, a data set that was produced by our Airflow DAG. So first, I need to start, and then I need to complete. And if I go back to my graph, and I click on, in this case, I did do a custom, let me reread. There's a custom namespace, so that's how you group metadata. And if I click on my custom job, you can see that now it's linking together the Airflow DAGs, which is on the left. It has my job called my custom job, and on the right, you'll see that now we have the input data set for that Spark job that we ran as part of the Lineage graph. And that ends our demo. All right, let me go back to the graph. OK. Very good.
And so just a quick pass on some of the things that are happening at the moment and are arriving soon. So as I said at the beginning, the goal of the OpenLineage spec is to be just a spec. Like everybody codes against it. So bootstrapping the project, there was an OpenLineage Airflow integration as part of the OpenLineage project, which is this plugin that inspects every task that's running and extracts the lineage and sends the OpenLineage event. And so earlier this year, the AIP 53 was voted on by the Airflow community. The AIP stands for Airflow Improvement Process. That's how you submit bigger changes to Airflow for approval by the community. So the AIP 53 was approved, and we're in the process of moving entirely the Airflow integration inside of Airflow itself, which makes it a lot more stable. Like instead of extracting lineage from the outside, it's part of the project, it's tested by the project. It's so much easier for anybody who has custom operators to add lineage support in them. And so that's one part of how OpenLineage is supposed to be working. And Airflow being such a big project, it's a big step for the project. We're also in the process of adding static lineage to OpenLineage. So as we discussed, right, we observe every run. The thing with that is we observe metadata only when something's running. And in a lot of time, you also have lineage before the job has run. You know the lineage exists, even if it has not run yet, but it's supposed to be running. And the absence of lineage sometimes is a problem as well. And so having the ability to collect that metadata as static lineage, knowing this lineage exists, for example, logical view in a warehouse or thing like that. We're in the process of improving the Flink integration. So the Flink integration was a bit experimental last year. And we're working with Flink maintainers, working in a big company was not sharing that they're working on that yet. And the big thing around the Flink support is we're adding a lot more around streaming data sets, right? Because a lot of that project had been focusing on batch to start with, and now collecting at least as well streaming lineage and collecting this information. And the last part that is being worked on as well, we started from generic Spark support, and that works for everybody who uses Sparks. And when you use Spark inside of Databricks, it works slightly differently. So we've been adding a lot more integration tests that are specific to Databricks and that run against the Databricks runtime to make sure that the lineage extraction for Spark works as well in the Databricks environment. So those are some of the things that are in the works coming soon. The first two are big items. And on that, the last part, if you want to join this conversation, of course, all of this is open source. It's on GitHub. You are welcome to join the Slack. Slack is the best way to communicate with the community and the project. You get invite links, so those bit.ly links, and you can follow on Twitter, where you get all the new releases, big PRs being merged, this kind of announcement, like meetups and community. And on that, we have 6 minutes for questions, which is great.